Hello students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. So I hope I am perfectly audible and visible to each and everyone present over here. Those who are watching this particular session, just mark your attendance here. So here today we are going to discuss some of more questions from the same chapter, carbon and its compounds. I hope you guys have revised the topics or the questions we have revised in the last class. Last class also we have seen some of the questions from the basic part of the carbon and its compounds. And the remaining topics or the remaining questions from the topics we will be discussing in this class also. So I think we can start now. So here is our first question, which of the following are allotropes of carbon? So when we are discussing about the carbon is having a versatile nature, right? Because of their some properties, so they are showing some allotropes. So here we need to identify which are the allotropes of carbon. Hi Nitu and Arush, good evening, welcome to the session. Read the question carefully. Which of the following are allotropes of carbon? Options are given here: diamond, graphite, fullerenes and graphene. Okay, let's see what is the answer. Arush is giving me the answer as option B. So option C is the correct answer, which means all the given compounds are the allotropes of carbon, right? Diamond, graphite, fullerenes and graphene are also considered as the allotropes of carbon. Arush, is that clear now? Okay, fine. Now we are moving to our second question. The reaction CH3-CBr plus H2 gives CH3-COH. What type of reaction it is? We have seen in the chemical properties of carbon compounds, right? We have seen addition reaction, substitution reaction, esterification and so on. In your syllabus, we need to focus more about the only those three compounds, right? Yes, diamond, graphite and fullerenes are the important allotropes you have studied in the, according to your syllabus only. So graphene is also another type. Clear? So what type of reaction it is? What you are observing here whenever we are treating an halogen compound, right? When the halogen compound is treating with water and alcohol is forming, what type of reaction it is? Okay, Nobita is giving me the answer as option B. Let's see what is the answer. Yes, option B is the correct answer, which is a substitution reaction. So what do you mean by the substitution reaction? Whenever any of the reactant are combined together, they will form a product in which one of the part of this molecule is substituted by other compound, right? Other part in the compound. So for example, here this CH3-CBr, right? Br is replaced by the OH group present in the water to form the corresponding alcohol. Clear? So there is a type of substitution reaction, replacement of an element or atom. Clear? Okay, now let us move to our next question. So this question is particularly based on the ethanoic acid. Two compounds we have studied in the concept class about the ethanol as well as the ethanoic acid. So here the question is, when ethanoic acid is reacts with sodium hydroxide, what will be the product formed? Read the question carefully. Ethanoic acid react with the sodium hydroxide. Okay, please give me your answers in comments. Okay, many of you are giving me the answer as option C. Let's see what is our answer. Yes, answer C is the correct answer. So what is the reaction happening here? What do you mean by the ethanoic acid? What is the formula of ethanoic acid? This will be our ethanoic acid or acetic acid, right? Whenever it is treating with sodium hydroxide or the base, this is a neutralization reaction, right? Neutralization reaction. Acid and base combine to form a salt as well as water. So what you are observing here, the hydrogen from acid part is releasing and oils from the base part is releasing to form a water molecule here along with the sodium salt of acetate, right? So this will be our reaction and the product will be sodium acetate. Okay, is there any confusion? What reaction it is? Clear? Okay, option is given here, right? So option D will be the correct answer. Is there clear now? There is any mistake in the answer? So I hope you understand. Now we are moving to our next question. Read the question carefully. Which process can ethanoic acid be converted into ethyl ethanoate? Samir, in which chapter you need the recorded session for this chapter? Okay, many of you are giving me the answer as option B. Yes, here option B is the correct answer, that is esterification. So here ethyl ethanoate is the compound which is known as the ester group, right? Ester compound. So whenever we are treating ethanoic acid with ethanol, right? What will be our product? So this is the esterification reaction. Ethanoic acid is reacting with ethanol to form ethyl ethanoate as the ester along with water. Clear? This type of reaction is known as the esterification. Is that clear? Is there any doubt in the reaction? Okay, fine. Now we are moving to our next question. Which reagent is used in the following reaction? A reaction is given here. This is our acetic acid or ethanoic acid, right? It will be converting into CH3CONA, acetate molecule, plus water plus carbon dioxide. So what will be the reagent that is used in the following reaction? So in the concept classes, we have studied about the chemical properties of ethanoic acid, right? First one, we have seen the reaction with the bases, right? Read the question carefully and compare with the options given here. Okay, most of you are giving me the answer as option D. Let's see what is our answer. Yes, option D is the correct answer, that is NaHCO3, right? Whenever we are treating the ethanoic acid with either carbonates or bicarbonates, right? Either carbonates or bicarbonates, it will produce the salt, corresponding salt plus carbon dioxide plus water, right? So the first one is the reaction with the bicarbonate. This is the sodium bicarbonate. If we are taking the sodium carbonate, Na2CO3, right? It will be forming the same result as well as the salt, carbon dioxide plus water. So whenever we are treating the ethanoic acid or acetic acid with the either carbonates or bicarbonates, they will produce the corresponding salt as well as carbon dioxide plus water. So as we are comparing the options given here, we can compare only that NaHCO3 is present here. Clear? Okay, can you move to our next question? Okay, Arush, is that clear now? Okay, this is our next question. Ethanol reacts with sodium and form two products. Which are they? Ethanol reacts with sodium. What are the two products formed after the reaction of ethanol with the sodium? So in the chemical properties of ethanol, we have seen the reaction of these ethanol with the metals, especially with the sodium metal. So what is the product formed in the particular reaction? Read the options carefully. You may get confused here. Try to write down the chemical reaction for this equation. Chemical equation for this chemical reaction. Yes, option C is the correct answer. Are you sure correct? So sodium ethoxide plus hydrogen, right? So how to write down the equation for the chemical reaction here? Ethanol. Ethanol means CH3CH2OH, right? It will react with sodium to form right? So this is not a balanced chemical equation. So this is the reaction whenever ethanol is treated with sodium to form corresponding ethoxide, right? This is an ether molecule. Sodium ethoxide plus hydrogen, right? So what will be our answer? It will be option C. Is there any doubt? Here is our next question. The question is based on the hybridization part. In the first part of the carbon and its compounds chapter, I have taken the concept of hybridization, right? So we have seen the sp hybridization, sp2 hybridization, and the sp3 hybridization. Here, some of the molecules are given here. We need to identify the one which is containing sp hybridized carbon atom. Arush, is there any doubt in the previous question? Okay, give me your answers in comments. Okay, many of you are giving different options. Let's see what is our answer. Option C is the correct answer, that is C2H2, right? So, hybridization we have seen sp hybridization, sp2 hybridization and sp3 hybridization. So, if you are asking about the alkane molecule, single bond carbon, right? Their hybridization will be sp3, right? So, if you are asking about the double bonded carbon atoms, alkenes, their hybridization will be sp2 hybridized carbon. So, for the alkyne triple bonded carbon atoms, they will be having the hybridization of sp. This is the important point you have to keep in mind. So, now you need to identify the one which is the alkyne in the given compounds. So, now what will be the answer? Now, what will be the answer? Which one is the alkane molecule from these given options? A triple bond is formed between the carbon atoms here, and this will be the structural formula of the C2H2 or ethane molecule. So, these carbon will be sp hybridized carbon. So, those who are having any confusion in the hybridization part, just watch our first part for the hybridization in the first chapter, which is given in our channel. Okay, I hope you understand. Now we are moving to our next question. The dehydration of ethanol results in the formation of. What is the product of dehydration of ethanol? Again, we have seen in the concept classes about the chemical properties of ethanol. We have seen the two types of reaction in the case of ethanol. So, one of the reaction is the dehydration of ethanol. So, what will be the product given here? Okay, there is no any structural formula is given. You need to give me the name of the compound. Yes, it is ethene, right? Ethene, which means option C will be our correct answer, ethene molecule. So, what is the specialty of this reaction? So, this is our ethanol molecule, right? Whenever I am heating this ethanol molecule at 443 Kelvin, 443 Kelvin in the presence of concentrated sulfuric acid. So, what we are observing here, the OH group from this carbon and one of the hydrogen from the first carbon will releases as a water molecule here. That is the dehydration process. To form CH2 double bond CH2, this is a double bonded carbon compound. This is an alkene, have the name of ethene because two carbon atoms are present here, right? So, ethene plus water is the reaction of the byproduct of this reaction. Clear? Is there any doubt? Okay, fine. Now we are moving to our next question. Read the question carefully. It is about the statement type question. Which of the following is an example of an addition reaction? Example of an addition reaction. So, in the chemical properties part, we have seen the substitution reaction, addition reaction, combustion, oxidation, right? So, here we need to identify the exact explanation for the addition reaction. Read the options one by one. First option is ethanol reacting with acetic acid to form ethyl acetate, and the ethene react with hydrogen to form ethane, ethane burning in the presence of oxygen, and ethanol reacting with potassium dichromate to form acetic acid. Okay, many of you are giving me the answer as option C, but our correct answer is option B only. That is the ethene reacting with hydrogen to form ethane. So what will be the equation for this reaction? Ethene means CH2 double bond CH2, right? Double bonded carbon atom, alkene. So we are adding hydrogen in presence of catalyst as nickel. So what you are observing here, hydrogen atom is added here and to form the ethane molecule. Alkene is converted to alkane molecule, right? So this is the addition reaction, and this reaction is known as the hydrogenation of alkenes. Clear? Now I have a question for you. If I am asking about the third reaction, what type of reaction it is? Ethane burning in the presence of oxygen. Okay, I hope my question is clear. What type of reaction is the ethane burning in the presence of oxygen? If you are heating any compound in the presence of oxygen, that is known as a combustion reaction, right? Combustion reaction. Okay, whenever I am discussing about the oxidation and combustion, I have clearly given the difference between combustion and oxidation, right? So if you are treating with any of the compound in the presence of an oxidizing agent, that's a type of oxidation. In the presence of oxygen, if it is treating, it will be the combustion, right? You must have idea between the difference between combustion as well as the oxidation reaction. Now we are moving to our next question. Read the question carefully. It is based on the IUPAC name of the compound. When ethene undergoes an addition reaction with bromine, the product formed will be. What is the name of the product formed here? Addition reaction of ethane with bromine. So whenever you are getting this type of question, try to write down the reaction. Try to write down the chemical equation for the reaction. Then you will get an idea about the name of this compound. So what will be the answer? So option A will be the correct answer, which means 1,2-dibromoethane, right? 1,2-dibromoethane. So what is the equation for the chemical reaction given here? Ethane molecule means double bonded carbon, right? CH2 double bond CH2. Then we are adding bromine, right? We are adding bromine. Then what you are observing here, this bromine is added to the two carbon atoms here. So it will be forming CH2Br. CH2Br. So if you are giving the naming of this compound according to IUPAC, we will need to find out the longest chain, right? So this is a 2-carbon compound. 2-carbon compound. If you are giving the numbering here 1, 2, which means at first and second carbon there will be 2 bromo groups are present. So dibromo ethane molecule, right? Dibromo ethane molecule. Is that clear? How to name the compound? So option A will be the correct answer here. This is the type of addition reaction given here with the bromine group. So this reaction is also known as the bromination. Is that clear? Okay, now we are moving to our next question. Here we need to identify the true statement according to the substitution reaction. Read the options carefully. Which of the following is true for a substitution reaction? Yes, Ayush, Arush, you are correct. Option C is our correct answer. That is the substitution reaction. It involves the replacement of one atom or group by another, right? We have discussed in our first question. So option C will be our correct answer, which is a correct explanation for the substitution reaction. We will be replacing any of the atom or molecule by another atom, right? So we will give the corresponding product over there. Here is our next question. Again, question is based on the esters part. Which statement is correct regarding esters? Read the options one by one. So options are given here. They are formed by the reaction of an alkane with water, and they are typically sweet smelling compounds. They are insoluble in water and due to their ionic nature, and they are more reactive than the corresponding acids. So what will be our answer here? It will be option B, right? Option B. So whenever you are asking about the ester is formed by the reaction of alcohol and acid. So they will form the pleasant fruity smelling compound or sweet smelling compound, which is used in the perfume production. I have already repeated in the concept classes. So this is the only true statement according to the esters, the correct statement according to the esters. Okay, I hope you understand. Here is our next question. Assertion reason type question. Assertion is ethene is an unsaturated hydrocarbon, and the reason is given that unsaturated hydrocarbons contain double or triple bonds between the carbon atoms. In the last practice session also we have discussed this type of question. So what will be the answer? We need to identify whether the assertion and reason are true or if it is a correct explanation or not. Okay, most of you are giving me the answer as option A. Yes, option A is our correct answer. That is both A and R are true, and R is the correct explanation for the assertion, right? So if you are asking about the classification of hydrocarbons, we will be dividing the hydrocarbons into two types. One is saturated hydrocarbons and other one is unsaturated hydrocarbons. In the case of saturated hydrocarbons, the classification is alkenes, which means they contain only single bonds. So in the case of unsaturated hydrocarbons, if it is containing double bond, it will be alkenes. If it is containing triple bond, it will be alkynes. Clear? So here ethene is an example of unsaturated hydrocarbon which contain double bond, right? So the reason is given that unsaturated hydrocarbons contain either double bond or triple bond. So both the assertion and reason are true, and it is the correct explanation. Okay, I hope you understand. Now we are moving to our next question. Try to solve the question. There is no any option for that. Write the name and structure of an organic compound X having 2 carbon atoms and its molecule and its name is suffixed with OL. Question is based on the IUPAC nomenclature. Read the question properly. We need to identify this organic compound having 2 carbons with the suffix of OL. So from the suffix we can identify which functional group it is, right? So we need to identify the structure as well as name of this compound. Okay, Ayush and Arush is giving me the answer as ethanol. So what will be the structure of the compound? So this will be the 2-carbon compound. 2-carbon compound means the word root will be ethane, right? Word root will be ethane and the suffix is ol. So from the suffix we can identify this is a functional group of OH, right? This is a functional group of OH. So how we can write down the structure of this compound? How we can write the structure of this compound? Two carbon compound, right? So 2 carbon is here and 1 is OH group. Now we need to balance the valency of carbon here. So here it will be CH3 and here it will be CH2. So CH3, CH2, OH is the structural formula of ethanol having the 2 carbon atoms with the suffix of oil. Is that clear? Arush, I think you need to revise more about this topic. You are getting confused more of the part here, especially for this chapter. IUPAC nomenclature and IUPAC naming is very important. First try to memorize those tables, which is the number of carbon atoms as well as their word root. Okay, this is another question which is the part of the first question. So here this is the compound X. We have seen X is the ethanol molecule here, right? Now the question is based on the second part here. What happens when X is heated with X is concentrated sulfuric acid at 443 Kelvin? Write the chemical reaction, write the equation for the reaction stating the conditions for the reaction. And the another question, also state the role played by the concentrated sulfuric acid in the reaction. Okay, I hope you got the idea about the question. In the first question we have discussed about the compound with 2 carbon atom having this functional group of OH, right? Whenever we are treating these particular compound at a 443 Kelvin as well as in the presence of concentrated sulfuric acid, what will be the product, what will be the equation for the reaction, and what is the role of this concentrated sulfuric acid in this reaction? 3 questions are here in the passage question given here. So try to answer this. So what will be the equation for this reaction? No answers? So here our compound X is ethanol, right? CH3, CH2OH. So what we need to do, we need to treat this with the excess concentrated sulfuric acid. Excess concentrated sulfuric acid at a temperature of 443 Kelvin, right? 443 Kelvin, which is given here. So what you are observing here, this is the dehydration process, right? Dehydration process, which means water molecule is released from here to form an unsaturated hydrocarbon, especially ethene or an alkene, right? Are you getting my point? So this is the equation for the reaction. Now what will be the role of concentrated sulfuric acid in the case of this reaction? So as we already know, this is a dehydration reaction, right? Water molecule is removed from here. So this is a dehydration reaction. So here the concentrated sulfuric acid is act as a catalyst as well as a dehydrating agent, which helps in the dehydration of the molecule. Catalyst and dehydrating agent, right? Is that clear? Is there any doubt in this particular reaction? This reaction is very important in the case of properties of ethanol. So ethanol will be converted into unsaturated hydrocarbons, especially in the case of ethene molecule. So whenever it is treated, this condition is very important at a high temperature of 443 Kelvin in the presence of X is concentrated sulfuric acid. Okay, fine. Now we are moving to our next question. Name and draw the structure of the hydrocarbon produced in the above reaction. I mean, in this particular reaction, what is the name as well as structure of this hydrocarbon? So structure will be CH2 double bond CH2, right? This is the condensed structure. So if you want to draw the expanded structure, it will be C double bond C, then right. What is the name of this compound? This is the condensed formula and this is the expanded structure formula. So what is the name of this compound? 2 carbon compound containing double bond. So 2 carbon means word root will be eth, and in the case of double bond the suffix will be ene, right? So this molecule is ethene. Clear? Here is our next question. Question is based on the isomerism part. After completing the IUPAC naming, we have seen about the isomerism part, right? So try to draw the 2 structural isomers of butane. So what do you mean by the isomers or the process of isomerism? What is the specialty? So isomers are having the same molecular formula but have their difference in their structures, positions or the functional group, right? So that we have divided the isomerism or the isomers into 3 parts: chain isomers, position isomers and the functional isomers. So here we need to identify the chain isomers of the butane, right? Chain isomers of the butane. As we already know, the molecular formula of butane is C4H10, right? C4H10. But stands for 4 carbon atom. Ane is the single bond which is in an alkane. So the general formula of an alkane will be CnH2n plus 2, right? So if I am putting the value of N is equal to 4, we will get the formula of this compound as C4H10. Clear? First we need to identify the straight chain formula, right? So this will be the straight chain formula of the butane. 4 carbon atoms are present. So total 3 plus 2, 5 plus 2 plus 3. Total 10 hydrogen is also present. So this is a C4H10 is a long straight chain compound of the butane. Now what will be the another possibility? This will be the branched chain structure, right? So if you are counting the number of carbon here, total C4 and again total 10 hydrogen is present, which means in both the cases they have the same molecular formula of C4H10, but the difference in their chain. This will be the straight chain and this will be the branched chain structure. So these are the 2 possibilities of isomers of the chain isomers of the butane. Is that clear? Now what about the second question? Draw the structures of propanol and propanone. Draw the structures of propanol and propanol. Propanol and propanone. Okay, in the case of butane, it will be one is a straight chain structure and another one is a branched structure. Now, our question is what is the structure of propanol? So propanol means 3 carbon compound, right? 3 carbon compound having the functional group of OH. So I can write on the structure here as CH3, CH2, CH2OH, right? This will be the structure of the propanol given here. 3 carbon atom with the functional group of OH. Now, which is the functional group present in the case of propanol? ONE suffix means it will be a ketone group. Ketone is having the functional group means C double bond O, right? So, this C double bond O is known as the ketone group here. So, when we are writing the propanol means 3 carbon atoms are present, right? 3 carbon atoms are present. So, this is the structure of the propanol molecule given here. Is that clear? Is there any doubt in the structure of propanol and propanol? So when you are writing the IUPAC name of this compound, we will be given the name of this compound as propan-2-on. Both propanol and propan-2-on interchangeably uses here in the case of IUPAC naming. And the common name is acetone. Okay, I hope you understand. Now we are moving to our third question here. Name the third homolog of alcohols as well as aldehydes. Alcohols as well as aldehydes. So whenever we are discussing about the homologous series, we have seen that in the case of any of the compounds like alcohols, alkenes or aldehydes, the two compounds which are differed by the CH2 molecule is known as the homologous series, right? So what is the first compound in the case of alcohol series? 1 carbon compound. First compound in the case of alcohol. So this is the alcohols, right? The first carbon compound in the case of alcohol is methanol, right? CH3OH methanol. Now we are adding CH2 molecule here, so we will be forming CH3CH2OH, this ethanol, right? So what is the third homolog? Again we are adding the CH2 molecule here, so it will be CH3CH2CH2OH, which means propanol will be the third homolog of the alcohol series. Clear? Now what about the case of aldehydes? Which is the first compound in the case of aldehydes? 1 carbon compound. It will be HCHO. HCHO means methanol or formaldehyde. Then we are adding CH2 molecule here. It will be CH3CHO. Ethanol or acetaldehyde. And third one CH3CH2CHO. It is propanaldehyde or propanol. Clear? So this will be the third homolog of the aldehyde given here, propanol. Is that clear? Okay, I hope you understand. Okay, now we are moving to our next question. Draw the structure of the following compounds. Name of some compounds are given here. We need to identify the structure of the following compounds. So in the case of IUPAC nomenclature, to find out the structure of compounds with the IUPAC name as well as the find out the name of the compounds with the structure is very important. Interconversion of this IUPAC naming is very important. So you must have idea about the number of carbon as well as their word root along with their functional groups. So what will be the structure of butanoic acid? Okay, what is the functional group in the case of butanoic acid? From the suffix, we can identify the functional group present in the case of butanoic acid. Is it alcohol, aldehyde, ketone or carboxylic acid? So the functional group present in the case of butanoic acid is the carboxylic acid, right? Carboxylic acid. And here the but stands for the 4 carbon compound. Along with the functional group, they will be having 3 more carbon atoms, right? So if I am drawing the structure here, 3, then 4, it will be CH3, CH2, CH2, COOH. This will be the structure of butanoic acid. Clear? Now, what will be the structure of chloropentane? Chloropentane. Yes, pen stands for 5 carbon compound, right? Pen stands for 5 carbon compound and ANE stands for only single bonds are present. So, I will try to write down the 5 carbons here, 1, 2, 3, 4, 5. Each carbon is having the single bonds in between, right? Then, here the substituent is given as chloro, which means any one of the carbon atom is containing chlorine as the substituent. So, I will add chlorine here. Now, we need to balance the valency of carbon by adding hydrogen atoms. So, it will be CH3, CH2, 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 Cl, right? Is that clear? This will be the structure of chloropentane. So, don't get confused with the C in the chlorine. It will be only 4 carbon compound. Is that clear? Here is our next question. 2 structures are given here. You need to identify the difference between these 2 structures. How are structure 1 and 2 given below related to one another? Give reason to justify your answer. Okay, I hope you can see the diagram given here. What will be the difference between these 2 structures, structure 1 and structure 2? Okay, first try to name the compound. So, what is the name of this compound? Name of this first structure. First, we need to identify the longest chain carbon compound, right? So, it will be, if I am starting from here, it will be 1, 2, 3 and 4. 4 carbon compound, right? 4 carbon compound. And what will be the name of this compound? If I am giving the naming here, we can see that in the second and third position of the carbon, there will be 2 methyl groups are present, right? So, it will be 2,3 dimethyl butane. Is there any doubt in the naming of this compound? What we need to do first, according to IUPAC, we need to find out the longest carbon chain compound, right? Then we need to do the numbering here. So, if you are getting any of the substituent as the alkyl groups here, you need to mention the position of this alkyl group. So, if I am mentioning here, in the case of second and third carbon atom, they will be having 2 methyl groups. Those 2 stands for the di here. So, dimethyl, 4 carbon compound having only single bonds. So, it will be butane. But stands for the 4 carbon, ANE stands for the single bonds. Is that clear? Now, what will be the name of the second structure? Again here also it is the 4 carbon common, right? This is the 4 carbon common. So I am giving the naming here. Numbering here, it will be 1, 2, 3 and 4. So what you are observing here, in the second carbon there will be 2 methyl groups are present. So the position of the methyl group will be 2,2-dimethyl butane, right? 4 carbon compound containing only a single bond. So 2,2-dimethyl butane. So what will be the molecular formula of this compound? Molecular formula of this compound. C6H14, right? C6H14. Okay, this is the structural formula and this is the IUPAC name and this is the molecular formula only with the number of carbon and hydrogen atom. So what you are observing here, in both these structures they have the same molecular formula but have this difference in their structures, so the chains, right? So this is the type of isomers is forming here. Clear? Is there any doubt? So this is the type of structural isomerism. They have the same molecular formula but have the difference in their structures. Is there any doubt? Okay, fine. That's all about from my side for today. We have successfully completed our chapter carbon and its compounds. So I have a request for you to revise the chapter completely. If you have any doubt in the any part of the carbon compounds, you can ask now. Then IUPAC nomenclature as well as isomerism part is very important in the case of carbon compounds, which will be helpful for you to give the basics of organic chemistry in the grade 11 as well as grade 12. Then, so this will be the last practice session for this chapter also. Then the next class I will be coming back with the next chapter, classification of elements and periodicity in properties. We will try to cover the basics of the periodic table there. Then I hope you guys enjoyed the session. If you really like the session, hit the like button, share this like to your friends also and subscribe our channel. If you want to get the session PDF, you need to join our Telegram channel, Infinity Learn 9 and 10 Telegram channel. You will be getting the session PDF after all the classes here. Fine? So thank you so much all of you. See you in the next class. Bye-bye. Pranay bhaiya, finish.